See, when an earthquake strikes, what happens to the two floors hidden below ground? Many engineers design buildings as if basements don't matter. But see, IS 1893-2016 thinks differently, and so should your STAAD model. Let's uncover one of the most overlooked but important seismic inputs, the GL parameter. See, it doesn't just change your results, it defines what part of your structure even gets counted in the first place. So let's first understand above versus below ground. Why it's different. See, seismic force distribution isn't the same for basement as it is for upper floors. IS 1893-2016 classifies seismic analysis based on where your structure sits relative to the ground level. So in buildings with basements, podiums or underground floors, ignoring this separation could completely mislead your lateral results. So let's understand what is GL parameter. See, GL stands for ground level, and in seismic definition settings, it tells STAAD where the ground ends and where the earth covered part of your structure begins. So if your STAAD model has floors below GL, you must declare the Y coordinate of using this GL parameter. Why? Because the code demands different treatment for seismic inertia effects above and below ground. So let's understand forces above ground level. Let's break down how seismic forces are calculated above ground. So you can check out this particular equation which I have specified over here from the code itself. And from this, when you combine them all, you will get VBS is equals to AH into WS, where, so you already know all these parameters. VBS is the base shear for the superstructure, AH is the horizontal seismic coefficient based on clause 6.4.2, and WS is the total seismic weight above ground level. So now you might think, what about below ground? See, for the levels under the surface, the rule shifts. See, here they have defined as WJ, which specifies seismic weight of the J level. Below ground, HJ, it's the height from the structure base, but here is the key difference. See, here your VB base shear for the underground segment will be AHR into W, where VBU is basically its base shear for the below ground portion, and AHR is reduced or interpolated value of AH, and WU is the seismic weight of the buried portion. So this is the main difference. Now let's understand the 30-meter rule and interpolation. See, IS 1893-2016 introduced an important rule. If the base of your structure lies the 30-meter or more below ground level, you should use 0.5 AH, and that is the half of the horizontal acceleration coefficient. And for anything in between 0 to 30 meter, use linear interpolation between AH and 0.5 AH. So let's understand this through an example. Let's say if a floor is 50 meter below ground level, AH used as 0.75 AH. This gradual reduction models how seismic energy dissipates through the soil before reaching deeper parts of the structure. Now let's understand why this GL parameter is non-negotiable. See, not defining GL in your seismic definition can be critical. See, STAAD will wrongly assume the entire structure is above ground level and applying full AH across all levels, even the buried ones. And this can lead to overestimating the seismic forces on the basements, wrong base shear values, inaccurate force distribution, over-designed foundations. So when you define GL Y coordinate, STAAD separates this VB above ground level and VBU below ground level, applies correct AH or AHR to each zone. Now as you can see over here, see, the total base shear VB is split into two parts. VBS, this is due to the seismic mass which is above ground, and VBU due to the seismic mass below ground. Now the code gives us tool to model this properly, but only if we use them correctly. So the GL parameter might be just one line in your input file, but it has a big job. It tells your software where the soil stops and where the structure starts. Now, if you are modeling building with the basement or underground spaces, make it a habit to define GL, use correct AH values, and check your shear splits. Now, if you like this breakdown, subscribe for more practical code insights, STAAD Pro tips, and real-world design explanations. Drop your queries in the comments if you are working on a project like this. I would love to hear your challenges. And always remember, don't just learn software, learn concepts. Thank you.